In this video, we will look at some of the elements that make up a basic audio system, signal management. As we saw earlier, loudspeakers can be built for intended markets such as installed, recording, live and touring, broadcast, and cinema. We can apply the same thought towards signal processors and mixers. Let's start with signal processors. So what is a signal processor? Well, it's not any one piece of hardware, although it can be, but more on that in just a moment. A signal processor is a tool that can enable us to shape the characteristics of an audio signal or group of audio signals. Just like we saw in the amplifier module, signal processors are available with different channel counts, although you'll mostly find them with just one or two channels. Signal processors can be broken up into a myriad of categories, and then those categories can be broken up even further into subcategories. Take, for example, an equalizer. We're all familiar with them, whether you know it or not. Have you ever jumped into your car and adjusted your bass and treble controls? Or maybe you've gone into your phone's sound settings and selected a preset that makes the program material more pleasant to your ears. Well, there you have it. You've adjusted an equalizer, and we'll just call it an EQ from now on. In most basic terms, an EQ is used to adjust the loudness of certain frequencies. EQs are available in different formats, most notably the graphic EQ and the parametric EQ. A graphic EQ consists of several filters. Think of them as level controls with a fixed bandwidth spread throughout the frequency range of 20 Hz to 20,000 Hz. They are typically used to optimize the performance of loudspeakers in a listening space. Parametric EQs earn their name through allowing the user to adjust multiple parameters, unlike graphic EQs which adjust frequencies that are a fixed width. A parametric EQ can control three aspects of each frequency: the center frequency, or the frequency that's being selected to adjust, the level, boosting or cutting, turning up or turning down, and the bandwidth. The bandwidth, also known as Q, can be made extremely wide or extremely narrow. Overall, if you need an audio equalizer, a parametric EQ permits finer adjustments than a graphic EQ. Then you have dynamic signal processors like compressors, limiters, and gates. Oh my! Have you ever listened to a presenter give a speech and in their excitement they begin to yell into the microphone? A sound engineer might rush to the level control for the presenter and quickly turn them down. But in a rush to adjust for yelling, the engineer might have turned them down too much. So now you're struggling to hear the speech when the presenter is speaking at a normal volume. The compressor is typically used to reduce program levels that pass above a user-defined threshold, allowing the overall average level of the signal to be higher. A limiter is a type of compressor which is used to prohibit an output signal from getting any louder. They are typically used to protect against clipping. Another example of a dynamic signal processor is a gate. A gate can be looked at as the opposite of a compressor, and signals that are above its threshold are allowed to pass through or gated on, while signals below its threshold are prohibited from passing through, gated off. Gates are useful when you are experiencing ambient noise through an open microphone. Set the gate's threshold just to where the noise disappears, but the source is allowed to pass through. There are many other dynamic signal processors, but we won't get into them here. Next, you have time-based signal processors such as delay and reverb. Delay can be used in a couple different ways. Either it can be used as an effect to replicate a signal n amount of times, or in terms of sound system reinforcement, it can be used to time-align side-fill or rear-of-house loudspeakers so that the sound that they produce is in sync with the sound coming out of the loudspeakers in the front of the room. Reverb allows you to simulate early and late reflections in an artificial acoustical space. You'll be hard-pressed to find reverb used in systems that require high speech intelligibility, but it may be a desired effect for a single instrument or group of instruments in a recording or live performance. Okay, we've only covered a handful of signal processors, but be aware there are many more. Signal processors can be arranged in various orders to produce a signal chain. The order in which you will place them will also have an effect on the sound. And depending on your application, you may have a very long signal chain or a very short one. The beauty of digital signal processors is that you can take all of these individual signal processors and put them into one compact device.